Now, let's learn about typecasting, a very important topic. Typecasting means forcibly assigning value of a variable of one data type to another variable which is of another data type. Type conversion happens automatically, but typecasting is done manually by the programmer. Let's say try to assign a value, but the two conditions of type conversion fail. However, if we still want to forcibly assign the value, we can try typecasting. Typecasting is done by specifying destination data type within brackets on the right side of equals operator. For example, int a equals 10 and byte b equals 20. Now we try int c equals b. Does this work? Int and byte are compatible with each other. Also, destination data type, which is int here, is larger than the source data type byte. So, type conversion happens and b gets stored in C. Now suppose we try to store integer data in a byte variable. C is now of type byte and we store a in it. Will it work? Destination data type byte is smaller than the source data type int. Compilation fails because type conversion rule is not met. If we still want to forcibly do this, we can try typecasting. For that, we will manually specify the destination data type within brackets, as shown here. This works, and the value of variable a gets stored in C. So, what didn't work with type conversion, we were able to fix using typecasting, okay? This is how typecasting works. Let's tackle some tricky questions. First question. The range of byte is negative 128 to 127. What will happen if we try to assign a value outside this range, like trying to store 130? Will it work? 130 is outside the range of byte and hence treated as int. Destination data type byte is not larger than int, so type conversion won't happen and compilation fails. But we just learned typecasting. Let's try that. We'll write byte within the brackets after equals, because that's the destination data type that we want to convert to. Will this work? This is valid typecasting, so code will compile. But what is stored in B? If you guessed 130, then that's incorrect, because even if you try typecasting, the range of bytes still remains negative 128 to 127. Let's find out what happens internally. If you try to store anything outside the maximum positive value of the data type, then the cycle is reset to the maximum negative value of this data type. If you try to store anything more than 127, then the cycle is reset to negative 128, and the counting will start from there. If you try to store 128 after typecasting, 128 is outside byte's range. It is 1 more than 127. So, when that cycle is reset to the negative range, 128 will correspond to the first number in this range, which is negative 128. So, 128 is stored as negative 128. Likewise, if you try to store 129, as 129 is 2 more than 127, the second value is stored when the cycle is reset to negative range. Hence, 129 is stored as negative 127. So, if we try to forcefully store 130, Java will count up to 3 places when the cycle is reset because 130 is 3 more than 127. Hence, when we print value of b, it shows negative 126 and not 130. This is called wraparound concept, so we've got to be careful with typecasting. Next, if we forcefully try to store negative 130 in byte data type, what would happen? It won't store negative 130, obviously, because the range is from negative 128 to 127. If you try to store anything after negative 128, like negative 129 onwards, then the cycle is reset to the positive max of the range of byte. If you try to store negative 130, negative 130 is 2 places after negative 128. So, when the cycle is reset to positive max, we'll count 2 places and that's the value. That gives us 126. Hence, the value stored is 126. Next, int I equals 21474833649. Will it work? Range of int is negative 21474836648 to 21474836647. The number in question is outside the range of int, hence compilation fails. Now here comes the twist. What would happen if we write the same number but using another format as shown on the screen? If you think compilation fails again, then no, that's not the case because this is valid code as per Java. How? How come the first one doesn't work but the second one does? Let's find out. Here's the question again, and this is the range of int. If you look closely, both the numbers are individually within the range of int. That is why it compiles. But if this compiles, what gets stored in I? Again, we're moving towards wraparound concept. If you try to store anything more than the positive range of int, then the cycle is reset to negative range of int. So, if you try to store 21474836647 plus 1, then there is no number greater than 21474836647 in int's range. Hence, the cycle is reset to the first number in the negative range. This is what gets stored hence. In the same way, if you try to store 21474836647 plus 2, the second number is stored, starting from the negative range, which is this number. Thus, this gets stored in I. Okay? So, we've learned a lot of tricky concepts in this video. That's all about typecasting, and this should make it crystal clear for you. That's all for now. See you in the next video.